Hey everyone, wanted to talk to you today about the NVRTX branch, how to install it, what it's useful for, and how you can get set up for it very easily. You might be asking, what is NVRTX? In short, it's our optimized ray tracing branch for the Unreal Engine. It's basically the repository for all of our ray tracing developments. So every optimization, every bit of fine tuning, every new feature, even new tools and editor support, it's all in there. It's all in one place. It's a collection of every technology we're working on. So what do I mean by that? NVRTX is a lot of things. I can show you real quickly. This is the RTX Showcase, and it shows you what you can do with some of our technologies, like RTXGI, RTXDI, DLSS. This is a fully ray traced environment. So for example, like you can go in here, you can turn ray tracing off and you can see what that looks like. You lose a lot of the dynamism and the penumbra soft shadows and so forth. If I turn this back on, you can individually see what the different technologies do. This is all right on our website. It's an executable you can download, and as you can see here, here's the project files. You can also get those. If you get the NVRTX branch, you can pull down these project files and begin developing with the branch right away. So individually, you can see, like, here's RTXGI and what it contributes to the scene, or ray traced direct illumination, RTXDI for short. You can turn that off and see what that does. Or, in the case of DLSS, where frame rates go up considerably by enabling it. So there's a lot that's in the NVRTX branch, and I'll go over that a little bit today. But first, I just want to run through what you need to do in order to get set up with it. And this is, I'm making the assumption that you're a bit of a first-time user. You don't build your own code. You're not used to this process. So I can streamline that for you, make it a little bit easier. There's really two things you need in order to install the NVRTX branch. You need to be set up with Visual Studio, and you need to get access to GitHub. GitHub is the repository where all of Epic's code efforts for the Unreal Engine are kept. And so this right here is our developer.nvidia.com/Unreal Engine website. And like right at the top, you'll see the RTX Showcase I was just showing you. And then we have the NVRTX branch you can get access to. And once you're set up on GitHub, all you do is just click through to this link and you're there and you have access to the code. To get access to the code, to get set up with GitHub, it's actually fairly simple. We have a quick link here on the webpage, how to get set up on GitHub. All you have to do is follow the instructions here. It's going to explain every nuance better than I can, but the high level idea is you have an Epic Games account. You just need to link that to GitHub, and this is it's like authorizing your Epic account. So once you step through this setup and get access to GitHub, there's not much to it. Step through the bits, and then you're in, and then you'll have access to the code. Now, if you've never used GitHub or you're not used to this sort of source control, there's lots of tutorials and instructions out there on how to use things like GitHub Desktop, which is free. You can download that and use it as a front end to access the code, and that way it's much easier to do regular updates. There's a lot to explain with all that. So if you're used to Git, fantastic. If you're not, don't worry. You don't have to do anything with that if you don't want. You can actually just download the code directly. I'll go with that because I'm going to step through these instructions as if you've never built code before, and this is not a usual thing for you. What you'll see is that once you go through just a few of these steps, it's actually fairly straightforward. It's not that big of a deal, and it's literally just a couple of button presses. You're building code, and off you go. But the rewards here, I would just point out, are incredibly powerful because this is the same system that gives you access to the latest Unreal 4 preview builds that Epic puts out, or even Unreal 5 development. So There's a lot of advantages once you get used to doing this. Once you're used to pulling your own code and building your own code, you'll find that you're able to do a lot more as a developer, even if you're not a coder. I myself am not. I'm designer artist background, so I don't know the first thing about building code, and even I can do this. So anyway, to get the code, once you get your Epic Games account linked up, click this button here. You'll see a green button that says code. Click that, and you can download the zip file. What you want to do is extract that zip file to a very logical location on your drive, someplace like C, Dev, NVRTX, a reasonable, logical, short path name. Because when you do the installation, it's going to generate a lot of folders and subfolders with very long, arbitrary names. It's going to look like it's pretty complicated. And the installer process can actually trip up because Windows has the 256 character limit. So what you want to do is just put it to someplace short and sweet, C, Dev, NVRTX, like I said, something like that. So here you can see that I've created a dev folder, extracted the contents of all the code to NVRTX, and here is the basic install. Okay, so the next step is getting Visual Studio installed. Visual Studio is made by Microsoft. This allows you to build code. There's very little for you to do here except install the software. So you can just do a Google search for Visual Studio. It'll come up as the top hit. And once you're here, the simplest thing to do is just pick Community 2019. Download that. It's free. And you'll have to make sure that you install the correct bits with it. But Epic has a nice page for that. If you look in their documentation, so docs.unrealengine.com, and search for Visual Studio, you'll see that they recommend you build with Visual Studio 2019. This makes you fully compatible with all the latest Unreal 4 and Unreal 5 code efforts. And when you're confronted with the installer, you'll just want to make sure you follow this. There are some installation details that you need to make sure you've included. You notice there's an Unreal Engine installer and a few other details. You'll want to make sure all those are clicked on and then run the installer. And none of this is anything that it needs to be too concerning, because even if you don't click on the right options, you can always go back to this installer and make corrections. Okay, so now that you pulled your code and you've installed Visual Studio, the next thing you need to do is you need to, here in your NVRTX installation folder, you'll notice two BAT files. There's setup.bat and generateprojectfiles.bat. Now, you're going to want to run both of these, setup first and then generate project files. You don't need to run setup if you pull your code like through GitHub Desktop or some other app method. Like I said, if you're used to pulling your code that way, you would have already gotten all the necessary setup files through that process. But if you pull the code manually, like we're doing now, you'll want to run the SetupBat. So that will launch. It'll do its thing, and you'll see it, pulling down basically, additional necessary bits that, the code needs in order to run. Okay, so the installer is done. Since you have Visual Studio 2019 installed, you can go ahead and generate project files. We have all the files we need, source files and everything. So just double click this and it'll just take a moment. Okay, and here you can see it's created a UE4.sln. That's your Visual Studio project file. So just double click that and get ready to build some code. Okay, Visual Studio is loaded up. All you have to do from here, very simply, is just select UE4 in the solution list on the right, and right-click it and say Build. Now, if you've done the installation correctly and everything, and you followed all the previous steps, it should just be automatic from here. So, you can see build updates as they happen. This process will take a little while. It depends on how fast your CPU is. If you got a lot of cores, it runs faster, but it could take anywhere from 15 minutes to, an hour or longer. Just depends on the speed of your system. One additional note is if you intend to make use of light mass, you might need to build it separately. You can do that very simply from the sidebar here. So scroll down in the list of your Solution Explorer to Unreal Lightmass, and you right click it and select Build. I've already done that here so you can see it building. Okay, once that's complete, I'll give you a couple of ways to find your editor. Just go back to your folder here. Two ways to do it, two easy ways. One is just go into the Engine folder, dig around here through Engine, Binaries, Win64, and I like to sort by type. And right near the top, you'll see UE4 Editor.exe, and you can double click that, make a shortcut, whatever you need to do. That's the editor. You can run that. And this is good for making a new project. But if you have an existing project you want to just use with the engine, an even simpler way is, for example, go into our samples folder here and go to RTXGI test. And let me make sure this is writable. You can right click any U project and say switch Unreal Engine version, and then associate it with the engine build you want. So in this case I'm going to go with this one because I've already got that one working, and double click it and it'll load the project on that version of the engine. Okay, first thing you want to do is enable the plugins once the editor is loaded. So let's go to plugins and do a search for NVIDIA. And right here you can see all of our technologies gathered up together. So for this I'm going to enable DLSS, real-time denoiser NRD, and RTXGI. So these three right here are some of our newest and most powerful rendering technologies. DLSS, of course, is deep learning supersampling. This is the method by which we take a lower res input image and scale it up and enhance the image, sharpening the edges and even creating detail on the fly using AI enhanced algorithms. RTXGI, RTX Global Illumination, gives you infinite bounce lighting in a ray trace setting. So just by itself, a very powerful rendering technology, very fast, very scalable. And NRD, the new real-time denoiser, goes hand in hand with RTXDI. RTXDI, short for direct illumination, is a technology that is built into NVRTX. So you simply enable that with a console variable. And what DI gives you is virtually unlimited direct lighting. So instead of putting only 2 or 3, maybe a handful of shadow casting lights in your scene, now you can put in hundreds, you can put in thousands. The capability of RTXDI is incredible. It's an amazing technology that is really powerful. It's enabling very much a next generation form of rendering. And in order to do such technology, we need to be able to take all the lights in the scene and gather them up and denoise them, render them in a single pass. So NRD helps with that. It allows us to gather up all the lights and basically render them all at once. Okay, so once you've selected the plugins you want to enable, just restart the editor and you're good to go. Now, of course, it should go without saying that any development, like this, when you're working with projects, or code branches and so on, it's a good idea to keep backups, different engine versions. They can, it's always possible it could change your content in some way, or it could make the content incompatible with some other version of the engine. And just for safety's sake, work from backup, use source control, the usual, safety protocols apply, but this is just a fast way to get into the NVRTX branch and get working with it. And in this case here, you can see our RTXGI simple project, where we've got a very basic example showing RTXGI working. You can see the cool thing about this little setup is, we've got the standard Cornell box over here and a rotating light, but these surfaces here that you see are completely emissive. There's no other point lights in here or anything like that. So they're just emissive mesh generating light. And you can see that's lighting that area beneath. You can see that this in here is, when it goes fully dark, it should be dark anyway, right? Except that this is generating light. And of course, this would affect all ray trace geometry in the scene. So any characters, world geometry, etc. It doesn't matter if it's static or dynamic or whatever. Everything receives that RTXGI lighting, whether it's from actual Unreal lights or emissive surface. But this is just a good test project so you can get up and running with RTXGI, understand how it works, and get into a few basics. This is a cool sample in that we've got a slightly more advanced test level in here that shows just a larger environment. RTXGI, of course, it provides you with infinite bounce lighting, and it's intended to run really fast. So, there's a few things to learn with setting up the RTXGI volumes, but once you do that, and you understand the ropes, and hopefully these samples here will make it a little bit easier to understand what you can do with it. But you can see all kinds of GI lighting is being created in this test scene here, and it's changing every frame as the directional light moves around, and get a really good frame rate out of it. So yeah, once you have NVRTX set up, now you can load up, for example, the Showcase and take a look at the attic scene and see how RTXDI is used in this scene. RTXDI is extremely powerful. It's really an amazing technology because it lets you do unlimited dynamic shadow casting lights in ray tracing. There's almost no limit on it. If there's a limit, it's kind of theoretical. But whatever it is, we've taken the upper bounds of what you can do with point lights from, a handful, maybe 2 or 3 or 4, not that many, you can count them on your hands, up to hundreds, thousands. In theory, hundreds of thousands or even millions. Although, I think a word of caution there's at some point there's a limit in any game engine where you can only go so far with so many objects before things start to weigh down. Well, whatever the upper limit is, it's a very high one. And just to demonstrate that, like I can grab, let's see, I'll grab all the point lights here. Yeah. And you can see there are a lot of them, right? It's a little hard to tell there, but this is the test environment, or it's the showcase. And so this is the showcase, and you can see all the light radiuses here. If I come back into the scene, you can see there's a ton of overlap going on. Every single light here is shadow casting. It has no limits put on it. They always render. There's no like max draw distances or any of that sort of thing. And in fact, like every, this is a blueprint actor, but each one of these blueprint actors here, they interact with the player. So as the player walks under them, they animate and sway back and forth. And each one of them has got a point light in them. I believe we can check the blueprint on that. You can see even in here, these have big radiuses on them, right? These aren't tiny little lights. They're all shadow casters. So just in this one spot, there is a ton of overlapping shadow casting lights, way more than you would ever attempt to do in real time. And you can see what the frame rate we're getting. right up here. And this is in editor too, so in an actual runtime situation with shipping code, your performance can be much better than this. You see what this performance is like. In fact, I mean, just for comparison's sake, and so you understand the tangibility of RTXDI and what it gives you. If just very simply, I can turn RTXDI off. So we go back to the sort of the older method of shadow casting lights and ray tracing. So when I make this switch, every shadow casting light will be treated individually instead of rendered all at once. That's what RTXDI does. It takes all shadow casting lights and renders them in a single pass instead of the old way of rendering dynamic lights, which is to render them individually one at a time. So that's why performance gets slower and slower the more lights you add, and we have to do tricks to cull them out and so on. With RTXDI, you don't have to do any of that. Just place the lights you want and let the system manage it completely. So here I'll turn RTXDI off. There it goes. So you saw that the frame rate was cut by more than half, and the quality didn't change. It looks the same. So RTXDI gives you a massive performance boost and maintains full ray trace shadow quality that you'd expect. So you get individual light penumbras. Everything is the technology is completely remarkable in this sense because, with unlimited lighting, you can just blast the scene with as many lights as you want, and it doesn't care about what kind of lights. They could be point lights, spot lights, rec lights, so on. I'll turn it back on so you can see that. So there you go. And you can see it's much smoother than without. This scene, in fact, was never meant for real-time rendering. It was originally done in Omniverse as a path trace scene. So it was intended for offline rendering, and I believe we're looking at something in the ballpark of 1.5 million or 2 million input triangles. So some fairly high poly geometry, some fairly, decently detailed objects, a lot of 4K textures and so forth, and it runs really smoothly. We also have a feature called hybrid translucency, and you can really see the effect of that. If I just turn off ray trace translucency here, so this is, we switch back to raster translucency. You can see what raster gives you. It's like not much, right? With ray trace translucency, you gain the soft shadow as an option. That's one thing you can do. And because hybrid translucency in our branch, what it does is it gives you sort of best of both worlds between ray tracing and raster translucency. So it's an option, but it's another way to go. You can, as you see here, when I turn off ray trace translucency, the index of refraction on the translucency remains identical, and that's because it's using the material settings the same as raster. So that's identical, but ray traced using hybrid translucency, you get a much deeper look. You get real reflections on it, but it's combined with raster support, basically. So raster materials combined with ray trace shadows and ray traced reflections. Yeah, it's really, like I said, it's the best of both worlds. It gives you a lot of capability and more options, another way to do translucency. Hybrid translucency also gives you compatibility with older particle systems, cascade particles. You might know that under ray trace translucency, you lose cascade particle compatibility. So hybrid allows you to be fully compatible with both Niagara and Cascade and have everything rendering correct. So what else can you do in NVRTX? It's got all these features, RTXDI, RTXGI, DLSS, tons of ray tracing enhancements. I'll step through a little bit of that, just show you where the documentation is. We have a tool called the BVH Viewer. And now the BVH stands for bounding volume hierarchy. And the idea with this is that every individual mesh in a scene has a world aligned box around it. And this box is for ray testing. So as rays are traced through the scene, we need to know if a ray is going to strike an object or not, and then what to do about it. If a ray is going to hit it or could potentially hit it, and then whether to do a calculation with that ray relative to that object or to discard it. But what this means is that excessive BVH overlap can also cost you some performance, because if a ray has to travel through several large bounding volumes, there can be, potentially lots of overlap, and these can create hotspots. So we have a tool here, which is under, you can go show, visualize, and then visualize BVH complexity. And there you can see that heat map I was telling you about. So, here you can see basically like this object here. It's a combined object, and it creates a kind of a large bounding volume, right? And you can see that they're all world aligned. So it doesn't matter how I have the object rotated. But if it's a really big object, a long object, and maybe it's cutting through lots of other objects, there is the potential for some performance loss that would only affect ray tracing. So yeah, so you can see that in real time. So as I move the TV around, there you go, and it's creating either more or less overlap. So the point of this tool is really information, and we give you a couple of different ways to look at it too. I can go back to here, visualize BVH complexity. I can do visualize just the overlap. So ignoring the boxes and just look at where it's hottest. And of course you want to get closer to black, right? Like if I look outside here, I believe there is a sky dome, but it's not being ray traced. So that's just rendered black as far as the BVH is concerned. It doesn't exist. And the closer you can get to blue and black, the better your performance is going to be. Now, some really hot overlaps may not matter all that much, because this is a tiny area. It may not cost a lot of frame rate, but of course, if you have a close-up shot, like a cinematic or something, and you're moving your camera right in here, and you're getting it suddenly, takes a hit in frame rate, this might be why, and this is a way that the tool can help you analyze that. So once you have this information, you can make all kinds of decisions, right? Like, do I want to organize objects in this particular way? It might help you figure out some more ideal groupings of objects. One decision that was made here, everything in here is an individualized separate object. But the structure itself was exported as one combined mesh. It was a perfectly valid thing to do. It's a high poly mesh. I think it's in the hundreds of thousands of triangles, but it was given optimized collision. Now, constructing the scene this way created a large overlap, because if the outer structure is one combined mesh, that means it's overlapping everything inside of it, all the smaller objects, and everything is shifted up slightly in BVH complexity just by default, because we're always ray testing against the outer structure. But even in this situation, it's not that bad. It's entirely acceptable, from a performance standpoint, to have a little bit of slack in BVH, where it doesn't need to be completely optimized. I think really most of the time you'll just want to make sure you're avoiding the red zone. Any place where you're doing, maybe sort of a kit bashed area where you have just tons of small object overlap, like all in one spot. Maybe it's a dozen or more objects and they're just all like overlapping each other for some reason. That's where you can end up with some pretty bad hotspots that might need fine tuning. And the tuning can just be as simple as merging objects, and Unreal has built-in ways to do that, using HLOD, or placing the objects differently. It could be that some objects don't need to be ray traced and you can take them out of the ray tracer. So lots of options there. But the point here is that you can see the sort of the heat map complexity of your scene and determine whether or not it's worth optimizing those hotspot points, much like material complexity and lighting complexity. So what else can you do with NVRTX? Well, we have the Caustics branch, and you'd want to use this branch if you're interested in using real-time caustic effects. As you can see here, you get light through ray-traced translucent surfaces with full like disbursement and light scattering and refraction and all the visual effects you'd expect to go along with real-time caustics. And it's based on the NVRTX branch, so all of the aforementioned technologies are also here. So you're not missing out on anything, you just gain caustics. And the reason why it's a separate branch is because this is a feature that's still under development. But if you go onto the code page here and you pull this code down, we have instructions here on how to make use of it, along with sample files, example projects. So you can get started with it immediately. There's a lot of good examples here, documentation, but everything you need is right here on the page in order to get going. So on the code page, if you click through to the GitHub, you'll see if you scroll down, we have all of the main documentation for NVRTX right here. So a lot of this can get very technical, and but every single new console variable or CVAR that we have is documented here. We tell you what it does and what the options are. And some of these, like, we allow you to do shadows and denoising in different ways. So there may be, like it says here, some quality trade-offs, but you can, there's lots of ways here for you to optimize your scene, fine tune it, improve ray tracing performance. Just stepping through this, and all the documentation you would need on features like hybrid translucency, light functions. We recently added world position offset support for instant static meshes and foliage. That's all right here. Foliage is now fully ray traceable. All the elements of foliage can animate and move and sway in the wind, and that all works. So we list that all out here. Here's a write-up on RTXDI, and steps you through what all the options are. And so this is in addition to the sample projects we provide with NVRTX. Just go into your install location, samples, and you can see those. In addition to that, all of our documentation is here. And if you need further reading or examples, we have a guide which will outline in even more detail like what the main features are and how to make use of them. So a lot of this is mirrored with the other documentation, but it's another way to read it, and maybe a more readable way to read it, but it gives you lots of different ways to understand what all your options are and how to best make use of them. And of course, the sample projects and larger examples like the RTX Showcase right on the main page, right here where you can download the project files, are meant to give you more advanced examples of how to make use of these technologies, how to incorporate them into your game. Okay, I just want to thank you for watching the video all the way to the end, and really appreciate you hearing me out on everything you need to do in order to install NVRTX, understand what it is, what it gives you. There's a lot to it. I certainly didn't cover every feature or every capability, but I just wanted to give you a high-level overview and really show that even if you're not a programmer, getting set up with Visual Studio, installing your own code and building it, it's not that complicated. It's gotten more streamlined over time. It's gotten easier, and hopefully you'll see that. So thanks again, and see you next time.